Okay, so for this problem, they want us to find the area of the shaded regions. And so from looking at the problem, we can find that we have two regions. We have one where, well, first our function, we can tell which function we're using for each one. So this function is similar to the cubic function, so we can tell that it's a function of degree 3, and therefore this will be this function up here. And this is a parabolic, which means that it would be a function, or at least from what we can see, it's parabolic, which means that this would be a function that has a degree of 2, and we can find that right here. It's negative, so it's upside down, and therefore we know that this is this function right here. And so from looking at this problem, we can divide it up into two intervals. We can divide it up into from -2 to 0, where this function up here is on top, and we will subtract this the bottom from the top and get an integral. Or we can, and then on this side we will take from 0 to 2 and do an integral where this degree 2 function is divided by you're subtracting the degree 3 function from the degree 2 function, and you're finding this area right here. And so if we wanted to do that, we'd have to set up two integrals. The first one would be integral from, we can see that they intersect at -2 and 0, so from -2 to 0 of 2x cubed minus x squared minus 5x, and that is minus the quantity, which is really important, x squared plus 3x dx. And so we can go ahead and solve this integral out, and then we can do the next region afterwards. And so for this one, we'll get 0, or from -2 to 0, -2 to 0, 2x cubed minus x squared minus 5x plus x squared minus 3x dx. And we can simplify this and go further from -2 to 0. So we can combine like terms, and so we can cancel out these cancel each other out, and we have a -5x and a -3x, which would be 2x cubed minus 8x dx. And then we can find the integral of this, and so we have power of 4, so x to the 4th divided by 4, we have 2 here, so we can do divided by 2, and then minus x squared over 2, but we have an 8 here, so we can just do a 4x squared from -2 to 0. And so if we were to solve this out at 0, we'd get 0 over 2, which is 0, minus 0, because 0 squared times 4 is 0, and then subtract this by the quantity of -2 to the 4th, which is 16, divided by 2 is 8, minus 4x squared. -2 squared is 4, 4 times 4 is 16, so we get a minus 16 here, and so we get -8 times the negative of the outside, and we get 8 as the area for this first region. So we have area equals 8 for region 1, so area of 1 equals 8, and so now we can find the area of region 2, which is from 0 to 2, which is from 0 to 2 of this function minus this function, which is -x squared plus 3x minus the quantity of the function 2x cubed minus x squared minus 5x dx. Simplify it out, we get 0 to 2 -x squared plus 3x minus 2x cubed plus x squared plus 5x dx. 0 to 2. We can cancel these out. We get a negative x cubed. We have these two which we can add together. And so we'd get negative 2x cubed, plus 8x dx as our final integral. And then we can go ahead and solve that out, which is basically the same thing as last time, to 4 over 4, but we can simplify x to the 4 over 4, we can simplify, and that equals x to the 4th over 2 negative plus 8x, which is derivative of this would be, integral of this would be x squared over 2 times 8, which is 4x squared. And then from 0 to 2 are our bounds. And so we can solve this out. And so we solve for 2. 2 is negative 8. We get 16 over 2, which is negative 8. Let's do this all in one thing. So negative 8 plus 16. 2 squared is 4. 4 times 4 is 16. And this is minus 0 to the 4th over 2 is 0. Plus 0 squared times 4 is 0. And we get negative 8 plus 16, which is 8 for area 2. And so if we add area, if we add area 2 plus area 1, which we have down here, equals 8 plus 8. And so our total area is equal to 16, and that is our answer.